A bicycle with 19-inch diameter wheels has its gears set so that the chain has a 6-inch radius on the front sprocket. Here is the front sprocket. And a 4-inch radius on the rear sprocket. The cyclist pedals at 195 revolutions per minute. Find the linear speed of the bicycle in inches per minute. So before we find the linear speed, let's just agree that when you are riding a bicycle, the rear sprocket is the sprocket that is moving the bicycle, or the entire bicycle, because the bicycle basically is going to use the rear wheel to push the bicycle. So our focus here is going to be on the rear sprocket to find the linear speed, because that is the sprocket that is going to move the bicycle forward. If you look at the front sprocket, so each one revolution the front sprocket makes, the rear sprocket is going to make the ratio of the gear revolutions. So for each one revolution, the front sprocket makes, the rear sprocket will make 6/4 revolutions. Okay. Our goal is to find how many revolutions per minute the rear sprocket is making, and then we're going to convert that into a linear speed, or we're going to use that to compute the linear speed. So when we say when the front sprocket moves, so on the front sprocket is the one that is attached to the pedal, so that is the one that is the cyclist is moving. So when the front sprocket moves 195 revolutions per minute, let's see how much the rear sprocket is going to move. So the rear sprocket will make that times the ratio. So it's going to make 195 times 6/4 revolutions per minute. So that is what the rear sprocket is going to make. Now, in order to compute the linear speed, we know that the wheel of the bicycle is 19 inches diameter. So the diameter is 19 inches. That is the wheel on the bicycle. So in order to find the linear speed, we have to find the parameter of the wheel and multiply that by the revolutions per minute the rear sprocket is making, because that is how fast it is going to go. So the linear speed is going to be equal to, let me compute how much is that. So this is going to be 292.5 revolutions per minute. Okay, so the linear speed is equal to the parameter of the wheel, which is, in this case, it is the diameter times pi. So pi times the diameter times the revolutions per minute the rear sprocket is making. So that is equal to pi times 19 times 292.5. Let me just, so this is going to be 19 pi inches times 292 revolutions per minute. Okay, so this is one revolution. So each one revolution is basically the parameter of the wheel, which is 19 pi inches per revolution. So now you're going to say, so revolution is going to cancel with revolution, and you're going to end up with 19 times, this is 0.5 by the way, So that times 19 times pi, it's gonna give me approximately, I'm gonna round it to decimals just like it suggested. So I multiplied that and I got 17,459.40 inches per minute. So that is basically the linear speed of the bicycle. In order to find the speed or how fast the bicycle is going in miles per hour, we need to convert inches into miles, and we need to convert minutes into hours. So I have, this is the first part, and then the second part, I have 17,459.40 inches per minute. I need to convert that into, first I'm going to convert the inches into miles. So I will need to convert first the inches into feet. I know that one foot is 12 inches. And then I'm going to convert the feet into miles. We know that 1 mile is equal to 5,280 feet. And then we're going to convert the minutes. So we know that 1 hour is 60 minutes. And now we're going to compute the answer. So it's going to be, this inch is going to cancel with that inch. This foot is going to cancel with that foot. And this minute is going to cancel with that minute. So we have 17,459.40 times 60 divided by 12 times 5,280. And this is going to be miles per hour. So I'm going to compute the final answer. So the answer will be 16.53 miles per hour. And that would be the second answer. Here is the first answer. So I hope this video helped you understand this question. And if you do have any other questions regarding this one, please let me know.